All right, let's get right into it. Today, we're talking about two fundamental states of energy that, and I'm not exaggerating, explain pretty much everything that moves in the universe. We're talking about potential and kinetic energy.
So, to kick things off, chew on this question for a second. You've got a slingshot stretched all the way back, totally still, and then you've got a bullet just rocketing through the air. I mean, they seem like complete opposites, right? But what could possibly connect them? Well, the answer is all about the physics of energy.
The thing they have in common is something called mechanical energy. Think of it as the total energy budget for an object. It's the sum of the energy it has because of where it is, like our still, stretched slingshot, and the energy it has because it's moving, like that speeding bullet. These two types of energy are always talking to each other, trading back and forth.
Okay, so let's look at the first type, potential energy. This is basically stored energy. It's energy that's just coiled up, waiting to be unleashed. The perfect picture for this? Imagine a skateboarder right at the very top of a halfpipe. Just paused for a second. They're not moving at all, but because they're way up high, they are absolutely loaded with potential energy. Now, this potential energy comes in a couple of main flavors. You've got gravitational potential energy. That's all about height. You know, the higher you lift a hammer, the more stored energy it has. Simple. And then you've got elastic potential energy. This is the energy you store when you bend or stretch something out of its normal shape. Think about pulling back a bowstring or squashing a spring.
So, back to our skater. They're sitting up there with all this stored potential. But let's be honest, stored energy isn't really doing anything interesting, is it? It's time to put it to work. So, the skater leans forward and drops in.
And bam! That brings us to kinetic energy. This is the energy of pure motion. The second that skateboard starts rolling, all that stored potential energy starts converting into kinetic energy. The skater is basically trading height for speed. And you can see that trade-off perfectly right here. At the very top of the ramp, they've got maximum potential energy. But since they're not moving, they have zero kinetic energy. But then, whoosh, by the time they hit the bottom of the ramp, it's totally flipped. They have almost no height, so minimal potential energy, but all of it has been cashed in for maximum kinetic energy. In other words, maximum speed.
So, you might be wondering, how do you actually calculate this stuff? Well, the formula looks like this. Don't let the math scare you, it's actually pretty simple. All you need to notice are the two key ingredients that determine kinetic energy: an object's mass, how heavy it is, and its velocity, how fast it's going. That's it. So, this brings up a really cool question. Looking at that formula, which one do you think matters more? Which one has a bigger punch when it comes to an object's energy? Its mass or its speed?
The answer is kind of surprising. It's the speed. And it's not just a little more important, it's a lot more important. How much? Well, check this out.
Here's the deal. If you double an object's mass, you double its kinetic energy. Makes sense, right? But if you double its speed, you get 4 times the energy. Why? Because in that equation, the velocity part is squared. It gets multiplied by itself. This is exactly why a tiny, fast-moving bullet can have way more destructive energy than a huge, slow-moving object. Speed is a massive game-changer. Okay, let's get back to our skater. The run is over, and they're just gliding along the flat ground until they slow down and stop. Now, we all know that fundamental rule of physics: energy can't be created or destroyed. So if their kinetic energy just went to zero, where in the world did it go? Well, this is where something called the work-energy theorem comes into play. It sounds complicated, but the idea is simple. In physics, work is just a transfer of energy. As our skater was slowing down, outside forces like the friction of the wheels on the pavement and air resistance were doing work on them. They were basically stealing that kinetic energy and converting it into other things, mostly a little bit of heat and sound, until it was all gone.
But hang on, there's actually one more layer to peel back here. It turns out kinetic energy isn't this single, simple thing. A moving object can actually have several types of kinetic energy, all happening at the same time. You can think of them as different flavors of motion. So what are these flavors? Well, first, there's translational. This is the one we usually think of, the whole object moving from point A to point B. Then you have rotational energy, which is just what it sounds like, the energy of it spinning or rotating. And finally, there's vibrational energy. This comes from the object's own parts kind of shaking or moving back and forth. And the coolest part? Our skateboarder has all 3 of these going on at once. They have translational energy as the whole unit, skater and board, moves forward. They've got rotational energy because those wheels are spinning like crazy. And yeah, they even have vibrational energy from the wooden deck of the board flexing and shaking a tiny bit. It's this incredible symphony of physics in one simple action.
So this all leads to a really cool way to sum up their relationship. Potential energy, it's a bit of a one-trick pony. It can really only turn into kinetic energy. But kinetic energy, it's the ultimate multitasker. It can be transformed into almost any other form of energy you can think of. Heat, sound, light, you name it. So, from a simple falling apple to a roaring sports car, this constant, invisible dance between stored potential energy and active kinetic energy is happening literally everywhere all the time. So I'll leave you with this thought. Now that you know what to look for, where can you spot this amazing energy transfer happening in the world around you, right now?